implementation of the smart sensor for automatic drip irrigation in the paddy cultivation. Actually, this system has been proposed by the Department of Computer and Electrical Engineering, ANA University. So, in this topic, we will focus in 4 things. The first one is the introduction and the problem statement, which will present by me. And the proposed irrigation system will explain by my friend Taha later on, while Siti will introduce the component and the technique used in the system, and Amalina will show you the result and discussion in the end of the Agriculture is important for the production of food supply chain to sustain the living organism on earth, and this activity needs water to grow the fresh produce and sustain the livestock. In agriculture, most of the water used for cultivating plants such as irrigation, the fertilizer and pesticide applications, and also for the crop cooling purpose such as the light irrigation. It uses 85% of freshwater resources worldwide just for cultivating plants using the traditional irrigation. Agriculture water comes from a variety of sources. The typical sources of the agriculture water is from the surface water, the groundwater from well, and also from the rainwater. The freshwater resources worldwide is only consists of 2.5%. Due to the scarcity amount of the fresh water worldwide for the agricultural activities, so this study is used precision agriculture methods to utilize the water resources for the paddy field irrigation. So the goal of this study is to optimize the usage of the water resources at the same time to ensure profitability in paddy cultivation. For the information, this research was located at Tamil Nadu, an area with 3 distinct monsoons such as the southwest, the northern, and the dry season, and the area are prone to drought. The gradually decrease in groundwater level and poor monsoon to the area for the past 10 years urged the researchers to concentrate on automation irrigation system to utilize the water resources. Based on the Times of India, the India's production rise recorded in 2017 to 2018 from June to July was 112.91 metric ton. In Tamil Nadu, rice constitutes 85.2% of total grain production. High demand of rice due to the growing population of India, it is expected that agricultural yield has to reach 70% by 2050, and this situation eagers the farmers in India adapting new innovation ideas and market forces. Most of the farmers, they are still using traditional ways to irrigate the paddy field, which is by using the flooding irrigation method. This flooding irrigation method is a technique that releases water into the paddy field until fully covered by water. About 1.3 million liter water required to raise an acre of paddy by using this traditional method in Tamil Nadu. However, the paddy crop does not require much water for its entire growth, as the production of rice require different amount of water in different crop stages. As you can see from the table, the paddy crops only need 25% of water during the early stage of cultivation, which is including the nursery and main field preparation. And much water is needed during the fully grown stage, from the planting to the ripening phase, which is 75% of water needed by the plant. The water requirement is critical during the vegetative phase and also the reproductive phase, as it will affect the formation of tillering, pedicle initiation and emergence, the bud leaf stage and also the flowering stage. The water deficit during these stages can cause the comparatively greater reduction. Therefore, it is important to introduce an automatic drip irrigation system as a water-saving technique in improving the rice yield. A general layout of a drip irrigation system that proposed by the ANA University in India can be shown. Drip irrigation is a network of perforated tubes linked to a water source. The water flows through pressurized pipes, vents, and drippers to make water drip slowly onto the soil. The use of drip irrigation can save nearly 40 to 80% of water as compared to traditional irrigation system, which only uses 0.4 million liters water to irrigate an acres of paddy field as compared to 1.3 million liters water by using traditional method. Thus, this research has introduced a new design of automation irrigation system based on the temperature, humidity, rain level, and light intensity in addition to the wetness of the soil. Automation system proposed the use of smartphone initially to capture soil image, calculate its wetness level, and transmit the data onto the microcontroller through GSM model, which also known as the mobile communication modem, intermittently. The microcontroller then decides the irrigation and sends the status of the field to the farmer's mobile phone. The methodology and working model of the proposed system will be explained in the next section.
Okay, so today I will explain about the proposed irrigation system. So according to SR Bar Command 2008, only 50 and 25% of the water volume is used and utilized during the early and mid stage of the paddy cultivation. Okay, there are various factors that affect the water requirements such as temperature, humidity, rainfall, and moisture content in the soil. So next, I will explain about the block diagram of proposed methodology. So the methodology was based on smart sensor, which consisting of several components such as arm, microcontroller, smartphone, GSM module, sensor unit, and motor control. Various sensors will responsible to gather the data and determine the wetness of the soil. An application is created to assist the farmers in controlling the irrigation system. Okay, now I will explain how the system works. We can see from the diagram here, the proposed irrigation system will capture the image of the soil, and then it can determine the wetness of the soil. The application will convert the captured image into a grayscale ranging 200 to 5000 pixel intensity, which is we call histogram. The histogram picture will be used to indicate the wetness of the soil. The ARM microcontroller depends on the wetness of the soil information to move the motor. There are three working systems of this irrigation, which is first one is soil is in dry condition and possibility of rainfall, so the motor need to be in the state off. And then number two is soil is in dry condition and the motor need to be off state. Lastly is the soil in dry condition and no possibility of rainfall. So the motor need to be in the state on. Okay, this system will continue to capture the image of the soil to determine the wetness of the soil in order for the microcontroller to assess on whether to irrigate the field or not. So, and lastly, all the status of the procedure will be continuously updated to the farmers via smartphone.
Assalamualaikum, I'm Siti. I will present on the component and technique used in the proposed irrigation system. Before I explain the component and the technique used, I will describe what sensor is a device that can detect and respond to some type of input from the physical environment. The example of the specific unit could be the light, the moisture, the motion, the heat, or any one of a great number of other environmental phenomena. Furthermore, the output is usually a signal that is converted to human readable display at the sensor location, or it will transmitted electronically over a network for reading or further processing. In this proposed irrigation system, the component that may include in the sensor is: the first one is temperature sensor, the second one is humidity sensor, the third one is rain sensor, and the fourth one is light sensor. As you can see from the picture, this is the temperature sensor. So, the function of the temperature sensor is used to find the temperature of the atmosphere. Thus, it will converting the physical parameter into an electrical voltage. The output voltage produced by the temperature sensor is linearly proportional to the instantaneous temperature. Besides that, this temperature sensor can sense from negative 55 degrees Celsius to 150 degrees Celsius. Besides that, this sensor can operate between 4 voltage to 30 voltage, and it linearly produces an output voltage of 10 meter voltage per centigrade in temperature. As you can see from the picture again, the analog output pin of the temperature sensor in the middle is connected to the output of analog to digital converter in ARM microcontroller. The second sensor is humidity sensor. This is the picture of the humidity sensor. The function of humidity sensor is used to find the presence of water vapor in the air. Therefore, the relative humidity is the common term used to measure the amount of water vapor in the air by adjusting the potentiometer in the sensor module, and the value is inversely proportional to the amount of resistance at a fixed temperature. Besides that, the humidity sensor is used which send the relative humidity in range of 20% to 95% at a temperature of 0 to 60 degrees Celsius in proposed irrigation system. The third sensor is light sensor. Usually we know what is the light function. The function for light sensor is used to detect the light intensity of the environment. The light sensor is a passive device which converts the light energy into an electrical energy. The fourth sensor is a rain sensor. This sensor is used to detect the rainfall in the field. The The sensor has two modules such as rain detecting and control module. For the control module, is able to produce both analog and digital output, while the digital output is used to detect the rainfall. Besides that, the rain detecting port has two separate PCB tracks in the dimension of 15 mm times 40 mm. The sensor board acts as a variable resistor which changes according to the waterfall on the board. The other component that used in proposed irrigation system is microcontroller. Microcontroller can be described as a compact integrated circuit designed to govern a specific operation in an embedded system. This microcontroller includes a processor, memory, and input or output peripheral on a single chip. This microcontroller is manufactured by Philips. Besides that, this microcontroller is more economical and reliable for beginners and high-end application developers. The important features in this microcontroller are 8 to 50 kb on the chip static RAM, 32 to 512 kb on chip flash memory, and 128-bit wide interface allow to 60 MHz operation. The operating voltage of the microcontroller is 3.3 voltage. Furthermore, the soil image processing is a technique used to examine the nature of the soil by progressing the captured image. This technique classifies the soil into different categories between completely dry to completely wet based on the wetness of the soil. The amount of wetness in the soil can be estimated from the histogram analysis of the captured image. Typically, the image captured from the smartphone are in color, which is mixture of three primary colors such as red, green, and blue. As you can see from the picture, this is the equation to measure the grayscale image. So I will show you the grayscale image that has been captured. The picture will enhance this histogram of the soil image and it will be shown in this picture. Histogram is the process of counting the number of pixels at a particular pixel intensity of the grayscale image, and the value lies between 0 and 255. From the pictures, the histogram result shows only a marginal difference between dry and wet pixels. So, to improve their differences, a setup is made to capture the image of a super white paper with the same background of illumination, then subtracted from the grayscale image. The next picture is a soil classification based on number of pixels. From the histogram analysis, the wetness of the soil is determined by the total number of pixels present in and around the pixel intensity 200. Based on the number of pixels, the soil is categorized into 6 different types which are shown in this figure. As you can see from the picture, the first bar is no wet content, while the red bar is a dry pixel, which is the first bar is completely dry soil. For the second bar, we can see that 15% is wet content, while the 85% is dry soil. For the third part is 30% is wet content, while the 70% is conditionally wet soil. The fourth one shows that the wet pixel is 60%, while the dry pixel is moderate wet soil, which is 40% only. The fifth bar results show 95% is the wet content, while the 5% is the dry pixel. The last part shows 100% of wet content. It is completely wet soil. Last but not least, the component and technique used is in the proposed irrigation system is irrigation application. The application is developed in Eclipse SDK 3.6.2 compiler using Java and converted into Android software package as an APK file. The application will be installed in a smartphone, which is placed inside a tightly water-resistant rectangular box with TARG on one side of the box. After that, the camera in the smartphone needs to be focused toward TARG to capture the soil image. In time interval, the application activates the camera module of the smartphone and capture the image, which is used to estimate the water content present in the soil. Furthermore, the application converts the RGB image into grayscale and determines the percentage of wetness by calculating the histogram. After that, the wetness percentage is transmitted to the microcontroller via GSM module, and the image, soil wetness percentage, data and time are stored in the smartphone memory to create a log file. This picture shows the image captured by smartphone application. For the right side is the black soil with different wetness level, and the left side is red soil in different wetness level. The last picture is the TARG setup that has been explained by me before. That's all for me. Thank you.
The smart drip irrigation can send the wetness of the soil to microcontroller and then decide the needs of the water to the field by capturing the image. So this is the hardware setup of the control unit. You can see here, this figure shows the motoring of smart irrigation system. This monitoring system shows environmental information, for example, humidity value, temperature value, LDR value, and weather. So this is very important to indicate the necessity of water for paddy. So this study was comparing the smart drip irrigation system with other existing systems. For example, manual or flood system and drip irrigation system. This figure here shows the different amount of water used by different types of irrigation system, which is manual or flood irrigation, drip irrigation, and smart drip irrigation. As you can see here, the highest types of irrigation that use the highest amount of water level is manual or flood irrigation and followed by drip irrigation. This is the clear result that smart drip irrigation method has the lowest amount of water used. This figure shows the percentage based on utilization of water by three different types of irrigation. Based on the figure above, The proposed irrigation system is clearly can save much more water when compared to other irrigation systems. When the manual system required 100% of water, the proposed system only required 58.57%. Next example, when the proposed system required 100% of water, the other irrigation system require higher than that. This figure here shows the water utilization from different type of system for 1 acre of paddy field. So the highest water utilization is from smart drip irrigation, which is 44.26%, and followed by manual irrigation system, which is 29.81%, and lastly drip irrigation system, which is only 25.93%. In conclusion, there is a need to amend the system for irrigation, as we all know the water, which is rainwater and groundwater, is decreased day by day. It is also important for area that has less water for irrigation. This smart system uses the application and capture the image, compute the wetness, and send the data into the microcontroller. And the system decides the needs of water in the field, and then send to farmers using SMS. This is the example of the SMS sent to the farmer. We can conclude that the smart drip irrigation can utilize water more than other irrigation methods. Besides, it also can save more water, and the overall cost of production